Hello folks, welcome. I'm going to go over the building of the exercise in Module 5, Modeling Information. And I found this to be somewhat difficult myself. It took me a while to think about what am I doing here. But I'm going to walk through it for you now, step by step, and build this model. So I'm going to start out the initial instructions really called for this idea that there's a planned average progress rate. And that's really a function of the scope and of the planned duration. And I'm just going to pull this down and put it here because I know I'm going to want it underneath. So I'm going to go up and click. I'm doing this in Stella, and there's just one thing that would be different in Vensim. So I'm going to add the variable planned average progress rate. And the idea is if you had a construction project or building a house or really a large construction project, how do you know if you're going to be on time or whatnot? You're starting out with the scope, and this is really the number of, in this case, it's work packages, or think of tasks that you have to do. And there's a planned duration. How long is this actually going to take me? What I'm going to do is I squared up, so I like squaring up my variables like that. And I'm going to go up to my connector, and I'm going to connect my scope, and I am going to connect the planned duration to this planned average progress rate. And what this is going to be is it's going to be the scope divided by the time is what it is. So I'm going to double click on this, and it's going to be the scope divided by my planned duration. And this is the number of weeks, and this is the activities. So this is going to turn into this work packages per week that I would have to complete. I'm putting these units in, and I've got that. And I'm just going to simulate the model, making sure it runs. It's doing what it was supposed to be doing. I'm just going to right click and view results here. And the idea of work packages per week, I'd be completing 400 per week, and I would finish in my planned time of 52 weeks is the idea here. And these work activities and my labor force and stuff are over on the left-hand side, and they're actually completing the work. Let me double click. They're completing the work, and this is draining out. Let me square some of these up also, so it's a little cleaner. And I've already done some of that, one of my pet peeves. But I'm going to add another variable here, and this is going to be the time required. And the idea is that it's the time required given how much work there's left to do and what my perceived or my planned average progress rate would be. This is everything going according to plan is what we're really saying. And this is time required. And again, my pet peeve of squaring that stuff up. I'm going to go up, and my work not completed is going to connect to this. And that new variable I added is going to connect to this. And this is how much I'm actually doing. And it's going to be divided into what I have left to do. And this time required is going to turn into weeks. So this is going to be work not completed divided by. And you can imagine what's going to happen is this is work not completed is going to be in work packages, and this is divided by work packages per week. I'm going to invert and multiply, and that's going to have my work packages cancel out. So this is just going to be in week or weeks, right? So click on that. My units are all correct down on the right-hand side. If you're in Vensim, you would be checking your units is all. Let me take advantage of all the space that I can here. And my time required, and this is one of the things I like to always have a running model, right? And so I'm adding things on gradually. Is it doing anything crazy? So if my time required, let's see what happens here. I was going to say, I want to check first. I was going to say, if it goes negative, I know time required can't be negative. I don't believe. But it's doing what we believe. And it's ending in 52 weeks. This is a perfect project at this point in time, right? And one of the things I can do with the simulation on, I can crank this up, and you can see what I'm doing is And this was in the instructions, this training switch. So I am turning the training on. So I'm sending a portion of my folks to train is what it is. And you can see that it ends up taking much longer because instead of doing the work, these folks are going and getting trained. So I have actually fewer people on the job at any particular point in time. My workforce has declined. And I'm just going to right click and view results for my workforce. And you can see how I've dropped my workforce for the whole period of time because I've just thrown them all in training permanently. So it's a way of testing to see what's going on. I'm comfortable with everything that's going on at this point. And now I can add, and it's going to be and this is basically for engineers, right? Engineers forecasted completion date. Or it's really the planners, I believe. But let's call this the engineers. Engineers forecasted completion. Tells me I'm spelling forecasted wrong, but I'm pretty sure I'm right. I'm going to leave it. I'm going to go up and I'm going to connect the time required. And in the instructions, what it suggested here is that we were going to add in time. So if you're in Vensim, you can go in and drop the time in here. Let's see, do they have... I'm sliding down with my built-ins, and time should be a built-in here. There it is. So I can just click on time and add it. So this is the running time, the number of weeks that is passing by. And this is going to be plus the time required. And imagine, ideally what should happen is my time is going to be increasing, but my time required is going to be decreasing because I am completing tasks. And this is keeping track of, considering how much work I've already done or how much time has passed and how much work I have left to do or how many weeks worth of work. And the units here are going to be in weeks. And this will track out the forecasted completion date. And let me just, I've added that in. My units are still correct. I'm going to simulate this now. And I'm going to right click and view results. And it's going along flat. Oh, and I've turned this training switch on, so I'm getting behind schedule is what's happening. So I'm going to hit this U-turn button or reset if I was in Vensim and simulate this one more time. Close that, and I want to view the results. And you can see that I'm on track to approximately week 52 there. And then the project's actually completed, so the time is just growing at that point, right? I'm just adding time onto this. So that makes sense to me. And now what we're arguing is that this will be going into an engineered schedule pressure was what the suggestion was. Engineer schedule pressure. Again, I'll square this up. And that's going to be a function of my planned duration and my engineer's forecasted completion date. Now double click, and this is simply going to be the engineer's forecasted completion date divided by my planned duration. And these should both be in weeks, so this will be dimensionless or a fraction. So, and if you think about this, I think a good rule of thumb, particularly starting out, one that I use all the time, is the idea that I'm pretty certain when I'm doing a ratio like this, that the variable that is constant is almost always, not always, but almost always in the denominator is what's occurring, right? And under ideal conditions, if I'm on time for my project, at least up to week 52, that this would always be 1. So I'm going to simulate this, and I'm going to right-click and view results. And look at that, it's 1 until the project is actually completed. And then because I'm running out for 100 weeks, the project is actually over, right? My work completed has declined and is gone at that point. And that's why that's increasing, because this is just the time. The time is still running on, so it's adding to the engineers and forecasted completion date in that formulation. So it's getting larger and larger. The numerator is getting larger and larger. And we could just take, this is just it's a ratio already, it's dimensionless. If this is greater than 1, the way this is formulated, then that would be the pressure to increase my schedule. And I'm just going to rearrange things here a little bit. And all I'm going to do is click on this, and my engineer schedule pressure is going to go to my work week. And if I double click on this, it's going to be my standard work week, which is 40 hours per week, at least in the States, times the engineer's schedule pressure. And imagine if this gets greater than 1, I'm going to multiply the standard work week by a number greater than 1. I'm going to increase the work week hours. And this is hours per week, which was that 40 under normal conditions, multiplied by this dimensionless. I'm pretty sure I'm good to go. I click on that and I'm fine. And now I've reset my switch. So if I simulate this, I can see my work completed is declining. Let's see if this is just always 1. This might be off your screen. Yep, it's 1 the whole time until the project is actually completed. And I'm not too concerned from that point. So I have closed this feedback loop, and this system is self-regulating now. So I'm going to do one other thing. Let me just throw a graph in here, and I'll get rid of this in just a second. I just want to make it clean, make it a little large. And because this is selected in the Mac, I can hold my Command key in the software and bring it down. And I'm going to do a comparative graph. And let's see, I'm going to override my thickness to make it 3, and I will allow numbers to be on here so I can distinguish between my runs. And what I'm going to do now is I'm going to turn this training switch on. And I want to do one more thing with the switch. I was putting a fraction out, but what I want to do is I'm going to go in, and you can do this in Vensim also. I'm going to go to an input range, and it's from 0 to 1. In the increment I'm going to change it, that's the precision here, is going to be 1. And if I run this, it's going to be the same thing. I really haven't changed anything. But now this will just jump up to 1. And I like that because I'm going to see the bigger change. I'm cutting my workforce in half, and it's happening at time 10. And you can see how it is actually increasing the length of time it takes me to complete this project is what it is, right? And if I didn't have these engineers in here, and I'm just going to do that just to show. So I'm going to just pull this back. I'm going to double click on my work week. I want to go to x squared, my equation. I'll get rid of that for now. I think I'll get rid of that for now. There we go. My model is capable of running. It is, the units are all correct. And I'm going to start fresh. I'm going to simulate, and I'm going to run the first run. And there I go. And now I can put my switch on, and I get even farther behind. I'm going to double click on the white space, and now I'm going to increase that engineer's pressure coming back to the work week. Open this up, and it's multiplied by that engineer's pressure. So they know they're getting behind, so they're telling people, let's work overtime, right? Contractors and stuff. Let's work overtime to get this stuff completed. And I'm going to run it one more time, and there will be a third graph that we'll pull up here. And again, this is the idea that you should have a mental model. Do you think it's going to be slower or faster before you simulate it? And then you're going to simulate it and see, was my mental model on or off in this case, and can I explain why there is a difference? And I'm going to simulate this, and there's actually an improvement. If you think about it, my work week, if I right click and view results, I can see my work week is increased. I'm putting a lot more hours in. I'm up to 60 hours. And then the project's actually completing at this point, so I'm not concerned about this point. So they're putting in 60 hours a week in order, and they're finishing sooner is what's occurring. So I'm just going to close this graph for a minute. I think I'm going to. There we go. I'll put it up here out of the way. And I want to add some additional structure. And Module 5 was about information delays in the system. And that's what we're going to add on now. And so I'm going to go up here, and I'm going to add a stock. And make this a little bit larger and double click, and I'm going to name the stock Project Manager's Forecasted Completion Duration. And let's see, can I close that? Now, I'll end up moving stuff over in just a second. Yeah, I just want to make it fit inside my stock. Again, that's just a preference. And I can slide this stuff over. I'm not going to be able to see everything at once. Model's getting a little bit large, but that's okay. So I'm going to go here, and it's going to need an inflow for this stock. And this is really a net change in project managers. Should have an apostrophe, yes. I'm going to skip that. Or completion duration. It's just the same name as the stock. And I know I'm going to need an adjustment time. It's going to take time for them to realize what is going on. And this is going to be the project manager's adjustment time. Now I'm ready to add the structure. So I've added 3 things, getting a little carried away. And I know what's going to happen is this engineer's forecasted completion date is going to be used here. Like a little arc. And I'm going to use information from the stock. I'm going to use information from project manager's delay time. So I'll go in and do the stock first. And this is going to be equal, under normal conditions, it should be equal to the planned duration. Now I could type the 52 in here and be good, and I can do this in Vensim also, planned, and there it is, planned duration, and I know that this should be in weeks. So I've got my units correct. If I back out to this flow, this is a goal gap formulation. And it's going to be in parentheses, and it's going to be typically what's coming in is what I'm looking at. This is the new or the current, and I'm going to look at what was the forecast, and they're going to adjust their forecast based on new information they're getting about how the project is actually going. So this is going to be the engineers minus the project manager's forecast at the time what they started out with. So they're starting out thinking it's going to be 52 weeks. If it starts to get longer, it would take them a little while to realize, we're getting behind schedule. It's not just a one-time thing. We should be doing something. I'm going to divide it by that adjustment time, which is the project manager's adjustment time. And let's see, I'm going to this is in weeks. It's funny that this is saying dimensionless down here. It shouldn't be doing that. The other thing I need to do if I double click, it's a buy flow. In Vensim, you don't have to explicitly put the buy flows in, but I do here. Oh, forecast it. Yeah, this is in weeks. I've got the right variable there. And this is going to be set to 2 weeks. And when it starts to get 2 weeks behind, they're going to become a bit concerned. Weeks. And I'm good. And I need to add a few more things here, or one more thing. And there's going to be the project manager schedule pressure. There we go. And that's going to be a function of the planned duration and the schedule pressure. And I think what I'd like to do right now is I'm going to break that link. I'm going to go up to my ghost variable, and this is a shadow variable in Vensim. I'll click on my planned duration. I'm just going to drop it down into there. I'll go to my connector, and I'm going to connect this. And I'm going to connect this back to my, I just didn't want my lines crossing. And you can see that this variable, it knows that its planned duration is supposed to be in there, so it's good to go. And the last thing I need to do is, not the last thing, but what I need to do is connect the project pressure. And what this is going to be is, this is the number of weeks that they are anticipating now based on their actual experience with this construction project. And this is what they planned on. So I'm going to take the project manager's forecast and divide it by the planned duration. And this will be dimensionless. And this schedule pressure is similar to this schedule pressure and will connect to my work week. And I'm just going to pull this work week down a little bit so I can get these. And I'll double click on this and open this up. And this is just going to be multiplied. So it's going to be times that project manager. So I have two things multiplied in here. And let's see, I'll make this a little bit shallower. And this structure here, this is the smoothed information is what it is. You're taking, and the idea is that information can be moved more than once, so I don't have to worry about conservation of mass or anything. It is a stock, it does accumulate, it can increase or decrease over time, which is why we have the buy flow. And it's information, meaning that I can use this information and it doesn't decrease the amount of information I have. If this was a manufacturing line and I had a stock of cars, if I used a car for some other purpose, if I drove it off the lot, the car is no longer on the lot. And that's the concept of this conservation of mass, that the stock, if I drove one car off the lot, the stock would have to decrease by one. But I can use information about things in a system or what's actually going on, and that information does not decline. And this we are calling an information delay. If you recall from the other videos, delays are captured in stocks. They're ubiquitous in these systems. So this does represent a delay, and it's an information delay, meaning it's taking time to accumulate or to change this information. And again, when the information is used, it's not going to deplete the amount of information we have remaining. So I'm going to simulate this one more time with this new link that's added. I've added a feedback loop to this system. And I'm going to find that graph and open it up. And now we are on run 4, and you can see that we're finishing a bit sooner. And what's occurring is with this information delay, there's more pressure coming into the system, right? I've closed one more feedback loop. You not only have the engineer's forecast getting off and telling folks you got to work a little harder, let's go. Now you have the project managers authorizing or hiring more people, or the work week is actually increasing in this case. And I'm going to right click and view the results for my work week. And you can see simulation 4 here that it's going to be a bit higher. These folks are working almost an impossible amount of time. They're going up. And I only care until the project. This data is really only appropriate till the project finishes in about week 60 here, or 70, excuse me, 69.5. So until 69.5, and I'm looking at this column on the far left. This is the time in here. So they're working about 70 hours a week, which is a lot. It's almost like you're in a law firm at that point trying to make partner or something, at least in the States. So that is fine and it makes sense. When I first scanned down here, I got warned that 145 hours in a week. That may be possible, but I'm wondering, off the top of my head, I don't know how many hours there are in a week. There are physical limits to these systems. This is not built into that model. But these are things that you should be aware of and should be warning signs that you can't work more hours in a week than there are actual hours in a week, not taking into consideration sleep and rest and eating and that type of stuff. So I'm going to close this, and we have one information stock here. And we're going to add in 2 more is what it is. And it's going to be the same structure. I think I'll stop the video here. It would be the same structure. But I could do this. And what the assignment was asking for is, can you do this for chief engineers? And then could you do it one more time for a VP of operations? And imagine how there are different levels in an organization and how this stuff leaks up. And one of the things you could do is, it could be that the information is leaking up and generating the pressure here, but this schedule pressure might be added up also, going to the next level, which would be the order of the delay would be the number of stocks in that system. So we could add more onto here, and each time we do it, and I think I'll just add one more on. And what I'll do is I'm just going to cheat a bit and copy these things, and I'm going to copy and click, and I'm just going to paste. And it puts a 1 at the end of all of these, and I'm going to go and change this at this point. So instead of project managers now, all I have to do is, this is chief Engineers, CHIEF. Chief Engineer schedule pressure, and this is going to be Chief Engineer. Chief Engineer's forecasted completion duration. And again, from Project Manager, I'm going to shift this to Chief Engineer. Again, I can model, but I can't spell very well, or maybe it's typing. And one of the things that changed in the instructions was that the adjustment time for the engineers is going to be different than the adjustment time for the project managers. And it indicated that this should be 5 weeks. So they're, just 5 weeks. They're not going to respond as quickly as what it is. They're going to wait a little bit longer. Maybe they're busier. Maybe it takes them longer for them to get information. Maybe they're managing multiple projects and don't want to overreact. And the schedule pressure, what I'm going to have to add, I'm going to ghost it in again. And it's the same thing here, is that, and that fixed itself because that variable was right. And this is going to end up connecting to, and as I'm going down with this, I'm going to hit the shift key and it'll put bevels in my connector here. And that's going to go to my work week. And if I look at my work week, it's just going to be times the chief engineers. And now, if I simulate this one more time, it seems to, so do I have an error in here somewhere and have not done, I haven't done this equation yet. I'm missing a link. And that link is from the engineer's forecasted completion date. And because it was the same equation as in the other place, it's just automatically fixing that for me. I'll get rid of that one. And the video is getting too long. I'm making too many typing mistakes. And now what we want to look at is this graph. Again, your mental model. What do you think is going to happen when I do this? It's even a little bit faster, even with the training switch that's back on. Let's just test it. Let me put the training switch off. And it's over what 1 was now too, right? It's back to the original. And if I increase and put that on, then I'm moving it out again. It's finishing quicker, but. And what the assignment asked for is one more, which was the Vice President of Operations, which does the same exact thing and feeds into the work week, and that would improve it a little bit. And the only difference there was their adjustment time was going to be 10 weeks. So you can see how these delays sort of build up. And I think that's enough for this video. It's gotten a bit long. Hopefully this is helpful. Feel free to reach out through Canvas and send me a note if you have questions or anything about this stuff. Thanks, and I'll see you folks around.